Hello again. This is latitude and longitude. So the idea behind latitude and longitude is that if we were to pick a spot right here out in the middle of the ocean, let's say, and say you were lost, you were out at sea and you were lost. If you knew your latitude and longitude, you could send help, so you can get help somehow. And the latitude and longitude is really just a grid system. It allows us to pinpoint locations based on a coordinate system, just like a graphing, just like you would do in math, graphing. And you've seen latitude and longitude before, and this hopefully, some of it will be a review, some of it will be new, and hopefully it'll combine with what you already know about latitude and longitude. If you can remember latitude and longitude as the ladder, the longest part of the ladders, the longest part of the ladders are the longitude, and the rungs are the latitude. That's the way that I've always remembered it. So latitude and longitude, we're always starting off at a 0 point. The 0 point in latitude is the equator, and the longitude, it's the prime meridian. And if we look back here, we have to have a reference point. So we're always going off of the equator. So we're either going to be going north of the equator or south of the equator. The lines are running this way. And the prime meridian runs right through a place called Greenwich, England. And that's where the first cartographers, the first map makers started. That's where they, as the English, as the British colonies were being, the world was being colonized by the Brits, they had to know where to send their ships and how people were traveling over the oceans. And so it was really important for them to design maps. And so because England was sort of the hub of the scientific endeavor of cartography, or map making, they were the central point. And so they just said, okay, we're the starting point. So here's 0 for us, and you can go to the west or to the east of England. And that's why that's the central point. So we start with the equator or the prime meridian as being the 0 point. And the lines are called parallels of latitude or meridians of longitude. And they're parallels of latitude because if you look at these lines run parallel to one another. But the longitude lines don't because they all meet at the north and south pole, so they intersect. So you can't have parallels of longitude as well as parallels of latitude. Just the latitudes are parallels. Longitudes are called meridians because meridian is a halfway point, and if you take any one of these lines, and I want you to envision taking a knife and slicing down one of these lines all the way around the Earth, and you would split the Earth in half. No matter which one of these lines you slice it along, you'll slice it in half if you just cut it along one of those lines. So that's why they are called meridians. So we have lines of parallels of latitude, meridians, as well as longitude. They run east and west. They're parallel to the equator for latitude. Longitudes, they run north and south, and they intersect at the poles. When we look at the way they just appear, these are just latitude lines. You can see they all run parallel. If you look at it from the top, as if you're standing above the North Pole looking down, it looks like rings, or bullseye, because they're in circles. The equator, here's that idea of that polar view. If you slice right here down the center of this, you'll get one half and another half. If you slice down any of these, you'll get half of the Earth. So that's why they're called meridians. Right? They measure in degrees north and south of the equator. So these lines run east and west, but they measure north or south of the equator. So they measure north and south. These measure east and west of this prime meridian, of this central point. And it's in degrees. So if we were to take this as our example, we're looking down at the North Pole. If let's say that this is our prime meridian, this one going from the center down to the bottom point here. Let's say that's 0. If I go 90 degrees, I would be right here, 90 degrees, and that would be east. If I continue another 90 degrees, I'd be at 180 degrees. and I would be all the way around, halfway around. If I start here and I go 90 degrees to the west, I'm here. I continue around to 180 degrees. Again, the the maximum amount of longitude would be 180 degrees. Here, if I go up from the equator, here's the equator. Let's imagine this is the equator. I'm trying to draw a decent line. And I go up to the North Pole, you can see that that is what angle? That angle right there is a 90-degree angle. It's a 90-degree angle. So 90 degrees get you to the North Pole. 90 degrees south get you to the South Pole. So 90 degrees of latitude is the highest. 180 degrees get you all the way around, called the international date line. We'll talk about where that comes from. So 90 degrees north, 90 degrees south, 180 degrees east or west. They're the exact same point. So we just call it, you can just call it 180 degrees. There's something interesting about latitude, and it has to do with a star called Polaris. Oh, not that Polaris, but we'll see why this Polaris, the symbol here for Polaris, the snowmobiles or four-wheelers or whatever you like to ride, that Polaris is a star, because Polaris is a star that is directly above the Earth's North Pole, and it's very, very far away. This is not to scale. So it's very far away, and it's directly above the North Pole. So if you're standing at the North Pole and you had to look straight over your head, you would see it. It's, if you're, and imagine, this is like a little picture that I found on the web. You're standing here, you look to the north. We call it the North Star because it's directly over the North Pole, and it helps us to find north, true north. So if here, this is the Big Dipper, you take the last two stars of the Big Dipper and in the pan, you draw a line from those, and it's the handle, the beginning of the handle of the Little Dipper. So that goes here, and that's the Little Dipper. So this is Polaris, the North Star. It's directly over almost directly over the North Pole, and it is significant. And it becomes very important when we start trying to figure out where we are on the Earth. And so I'm not sure why the company decided to use that as their symbol, but it makes sense because it is the North Star. And if we look at our notes, you'll see that you have that drawn here. One of the things, and we'll talk more about this, is this altitude of Polaris is equal to the person's latitude north of the equator. So your altitude of Polaris is equal to your latitude. So if we're back here, altitude means going from the ground up to the star. So if you had to go up 20 degrees, then you would be at 20 degrees north latitude. If you go up 80 degrees, then you're at 80 degrees north latitude. And we'll talk more about that. But that's the help that is helpful when we're trying to find out where we are on the Earth. And longitude has to do with time zones and how fast the Earth moves. So time zones are very important to longitude. We spin 15 degrees, we rotate 15 degrees per hour, and places with the same longitude have the same solar time. I'll come back to this slide in a moment, but basically, if you were in anywhere on the East Coast, this is not a great example. Let's say here in Africa, if you're here, or if you're here, you have the same solar time. So it's the same time of day. And this is what sets up our time zones. So that as you go this direction, so if you were in England and you were to call somebody in New York City over here, they would be in a different time zone than New York City. And they would actually be about 5 hours ahead of us. And that's why we have in the United States, we have the different time zones. We'll talk more about time zones later on this week. But just know that because we're spinning on our axis, that gives us different times, because when it's daylight here, on the opposite side of the Earth, it's nighttime. So if it's noon over here, it's going to be midnight over here on the opposite side of the Earth. and we break up the Earth spins about 15 degrees every hour, so we have each time zone's about 15 degrees of longitude apart from one another. And we'll spend some time in class discussing that a little bit more. And here's the longitude notes. If you didn't finish those, finish the survey before you and turn that in. Answer the questions there, and you're done with these notes. If you have any questions, please put them in the notes summary.